Day 272 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 502, IPO. The difficulty level is hard, but don't worry because we're going to keep the solution as simple and easy to understand. So let's get into it. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description. Now let's see what the question says. Question says, suppose LeetCode will start its IPO soon. In order to sell a good price of its shares to venture capital, LeetCode would like to work on some projects to increase its capital before the IPO. Since it has limited resources, it can only finish at most K distinct projects before the IPO. Help LeetCode design the best way to maximize its total capital after finishing at most K distinct projects. You are given N projects where the ith project has a pure profit of profits I and the minimum capital of capital I is needed to start it. Initially, you have W capital. When you finish a project, you will obtain its pure profit and the profit will be added to your total capital. Pick a list of at most K distinct projects from given projects to maximize your final capital and return the final maximized capital. The answer is guaranteed to fit in a 32-bit signed integer. All right, y'all. It's a little lengthy question. It's a lot to take in there. It's kind of difficult to understand. So let's go ahead and look at these examples so we know what it is exactly that they want us to do, right? So in example 1, we have the input K equals 2, W equals 0, profits equals an array of integers 1, 2, and 3, and capital equals an array of integers of 0, 1, and 1. The output is 4. So I know you're probably trying to figure out how did they get this output from this input, right? So let's look and see what the explanation says. Explanation says, since there's initial capital of 0, you can only start the project at index 0. Okay, so we have W right here. That's our initial profit. So let's come over here. Our initial profit is or our initial capital, is 0, which means we could only pick one of these projects that has 0 capital or that we only need 0 capital for. In this case, there's only one project we could do for free. Basically, that's what 0 capital is, right? It means we need a project that we can do for free. And when looking at these projects right here, there's only one project that requires 0 amount of capital, right? And each one of these projects correspond with the profits, each one of these projects, and these represent the profits that we'll get from one of these projects. So the first project we have to do is 0, right? It says, since your initial capital is 0, you can only start at the project index 0. So since right now W equals 0, we can only afford to do this project right here. Boom. So we do this project and now we get $1 profit, or we get 1 profit, boom, for doing this first project. So we could just come over here, we could put 0 plus 1, right? Because we made a profit from doing this project. Now W is equal to 1, right? Because 0 plus 1 equals 1. So now W equals 1. So we could just come right here. We'll do it like this. Equals 1. Boom. Then, so now that we have $1 or 1 capital, right? Now we are able to complete either one of these. It says right here, after finishing it, you will obtain a profit of 1 and your capital becomes 1. With a capital of 1, you can either start the project index 1 or project index 2. So boom, we did this project right here. This corresponds to the amount of capital we get or the amount of profits we make from doing that project index 0, right? They correspond. So now we add, this turns into 1, right? So now we have 1 profit. Boom. With 1 profit, we could either do this because this requires 1 profit to complete, or this project right here requires 1 profit to complete. So we can choose either one, but you have to remember K equals 2, meaning we can only do 2 projects, right? It says right here, pick a list of at most K distinct projects. So we can only do 2 projects because K equals 2. So since K equals 2, and we can only do projects. We already did one, so we could get our first capital. We already did one project, so we only have one project to pick from left. But remember, we want to maximize the final capital, which means so we could either do this project or we could do this project. But this project at the end is the one that's going to maximize our final capital, and they both cost the same. So we're going to choose to do this project, right? So boom, we do this project. That's the last project we do. And that's when we come over here. 1 plus 3 equals 4. Boom, just like that. So that's where this comes from right here. If we got rid of this 0 plus 1 equals 1, it looked the same, right? So we go 0 plus 1 plus 3 equals 4. Boom, just like that. But we could just this was just in there so we could show a step-by-step basis, right? So boom, that's how we got to 4, just like that. We did our first project, which we only needed 0, but it got us 1 profit. Once we had 1 profit, we were able to choose between either one of these because each one of these takes 1 capital to complete. So since we can choose either one of these and these correspond to these, we're going to use this one, the third or the second index, and get a profit of 3, which is how we got this 3 right here. And we add those total profits together. 0 plus 1 plus 3 equals 4. Remember, this 0 is the initial capital, and this 1 plus 3 is the 2 projects that we were allowed to do. Remember, we started at 0 before we did any projects. So boom, that's how the question works. Let's go ahead and look at example 2 so we could really bring this home for people that might not understand it yet, but it's pretty simple once you get the hang of it. So in this case, we have in example 2, we have the input k equals 3, w equals 0, profits equals an array of integers 1, 2, and 3, and capital equals an array of integers 0, 1, and 2. This time the output is 6. So let's come over here, put our w equal to 0 to start so we could do our math. So boom, since w equals 0, that means we only have enough capital to do this first project. Boom. And we know this first project corresponds to this first amount of profit. So we're going to get 1 profit from this first project that we do. So boom, we do this, and we can do up to 3 projects this time, whereas before we could only do 2. So this time we have 3 projects to do. So boom, we do this first project, and we get a profit of 1. So we have our profit right there. Boom. So boom, then now we can only we have our w equals 1 now, right? So we just say equals 1. Now that w equals 1, we can do this project. At first we couldn't do this project because we didn't have enough capital because it was only $0. So we did a project, got some profit from that project, and now we have 1 capital that we can use to do this project. Boom. So we do project at index 1. That corresponds to this amount of profit. So we get 2 profits this time from doing project at index 1. So we can go plus 2, and that'll give us 3, right? So now we are at 3 profits, right? So now, and just keep in mind, you don't lose any profits when you do another project. You just have to have that amount of capital available to do the project, but you're not going to lose any capital when you do the project. But now that we have 3 capital, or $3 or whatever you want to call it in our capital, now we can complete this project because this project only requires $2 or 2 capital, right? Equivalent of 2. And since we have 3, we can complete it. So we complete this project, and that gives us a profit of $3 more, right? So we can add 3 to this. Boom. And 3 plus 3 is going to give us 6. Boom. So that's how we got it. So if we took these equals away, we could just take that away, and we could take that away. As you can see, it'll still go 0 plus 1 plus 2 is going to give us 3, plus another 3 is going to give us 6, and our output is 6. So I hope that made sense to y'all. If it didn't, go ahead and look over that, or go ahead and rewatch that example so it could really make sense and you really understand what the question is asking. Because in order to write a good solution, you have to know what the question is asking so that we can get the solution correct. So it's very important to understand what the question is asking in order to understand the solution. But now that we understand the question, y'all, let's get into the fun part, the actual solution, y'all. And the solution is not as difficult as understanding the question at all. It's not even that much code. So let's get into it. Now, the first thing you do, now if you're writing this on Xcode, first thing you need to do is you need to import collections. Boom, just like that. You don't have to do it for the LeetCode, but if you want to do it in Xcode, then you're going to have to import collections. Then after you import collections, now we need to sort the project indices in descending order based on the required capital. So in order to do that, we could just come right here and we can declare a variable called indices, and we set that equal to capital dot indices dot sorted. Boom. My bad. Let me just make sure the spelling is right. So capital dot indices dot sorted. Then we're gonna open up the brackets and we're gonna say capital. Capital. Then we're gonna open up the square brackets. We're gonna put a $0 in between. Now this $0 just represents each element in this capital array. So as we are iterating through the capital array, this $0 is going to represent each element for us. Then we're going to say is greater than, we're going to come outside of this and say greater than capital, open up the square brackets, $1. Now this $1 is going to represent all the other elements in the array, right? So say this would be $0, then this would be $1. You know what I'm saying? If it was like a for loop, it would be like this would be for I in capital and this would be for J in capital, or I plus 1 in capital. You know what I'm saying? So, boom. Now we need to create a max heap, which will store the available projects based on the profit. So in order to do that, we're just going to come right here. We're going to declare a variable. We could call it heap, and we'll set that equal to a heap. Then we put the less than sign, integers, greater than sign, parentheses, just like that. Now we need to iterate up to k times to pick the most profitable project. So in order to do that, we come right here, we can say return, open up the parentheses, we'll say 0, less than k. So 0 up to k, come outside of that, we'll say reduce, reduce, open up the parentheses into W. Then we're going to come outside of that. We're going to open up the brackets. We're going to say assets assets, comma, underscore in. And then we're going to open up the brackets. And now we need to add all projects that can be afforded with the current asset to the heap. So in order to do that, we're going to come right here. We're going to say while, exclamation point, indices dot is empty, comma, capital, open up the square brackets, open up the square brackets, indices. Sorry, y'all, gotta make sure the spelling's right. Indices dot last, exclamation point. Come outside the square brackets. We're gonna say is less than or equal to assets. We're gonna open up the brackets again. Now we need to add the project's profit to the heap. So in order to do that, we're just gonna say heap dot insert, open up the parentheses, profits, square bracket, indices dot pop last, parentheses, exclamation point, just like that. Now we need to pick the most profitable available project and add it to assets. So we could just come outside of this while loop and we say assets plus equals heap dot pop max, parentheses, question mark, 0. Boom. So let's run this. Hopefully it runs like it's supposed to. No errors first try. Ooh, okay, we got an error. in the first try. It says expected separator. And so let's see where we went wrong. So, oh, saw it. Oh, no, I thought I saw it, but I don't. That's not it. Let's see. See what else it says. So somewhere, oh, is it right there? Nope, not right. Oh, right here. Sorry, y'all. There it is. That should not have a space in between it. So let's go ahead and run it again, see if it runs this time. Let's see. Oh, so it's still something up there we got to fix. We have to fix. Maybe it's right here. Should it be equal white space? Let's see. Let's see. Nope. Oh, well, that fixed that. Dang, we got a lot of errors this time. So right here. So now we got to fix up top. So we have sorted. Let's see, y'all. What is going on? What does it say? No member indices. So something with the spelling. Indices. How we spell? Oh, sorry, y'all. So this should not have an I in there. Let me just take out the I in all of these, because just to keep it right, I had the spelling wrong. So we get rid of these I's. Should be indices with no I. Let's run it this time. See if that works, y'all. Let's see. And it's accepted, y'all. That's what I'm talking about. Your determination and your consistency has to be unmatched. You have to keep going and keep working through the problem until you get it. You're not always going to get it on the first try, but you cannot let that stop you from trying again. You always got to keep trying until you get it and understand where you went wrong. And look at that, y'all. 33 milliseconds beats 62.50% of users with Swift, y'all. Not too bad, not too bad. We'll get those numbers up as we continue down our LeetCode journey. Right now, we just want to be able to solve the problem that was presented in front of us. And I feel like this was a good solution for that. We're doing heaps now, so we had to use some heaps. So I hope y'all learned something today, and I hope to see y'all tomorrow for another day, another LeetCode problem. See y'all then.